Hey everybody, I have a project that I'm getting started with that I'm really excited about. I'm going to do some videos of it so you can kind of watch as I work on this. But this is a 3.8 liter supercharged engine from a 1989 Ford Thunderbird. And the project, as far as the engine rebuild, has been started by somebody already, and unfortunately they weren't able to finish it. So I'm going to kind of pick up where they left off and go through, measure all of our clearances here, and then get the engine put back together. Make sure everything is all tight and where it's supposed to be, and then hopefully we can get this back in the car and hear it run before too long. So I hope everyone enjoys the video. The first thing I wanted to do with this engine is just pull the bottom end apart. Since it came with the crankshaft already installed, I just wanted to make sure that all the bearing clearances were okay. What you see me doing here is using plastic gauge. Plastic gauge is a thin strip of plastic that you actually lay on the bearing and sandwich in between the bearing and the mating surface, and you torque the cap down, and you literally squish the plastic out and you read the thickness of the plastic. Just kind of a quick check to make sure the bearing clearances were okay. The lower end of this engine was supposed to be new when I got it, so I just wanted to double check that, and it was, and everything was good, so I could move on from there. Once I had the crankshaft measured and checked and everything was good there as far as the bearing clearances go, I was able to move on and do the same thing with the connecting rods. The connecting rods were a little bit trickier to get to, but certainly not impossible, so I was able to use plastic gauge and double check the bearing clearances there, and everything also checked out good with the connecting rods. Once I got the main caps torqued back to spec, I checked the clearance between the main bearing caps and the crankshaft with a feeler gauge. A feeler gauge is a set of super thin little pieces of metal. As you can see there, there's many different sizes. They basically just measure the thickness between the two components that you're checking. All the specs were good in this crankshaft. Here you can see me attaching a dial indicator. I used a dial indicator to check the crankshaft end play. It's basically the movement that the crankshaft can slide back and forth in the block. That movement is controlled by the thrust bearing, which was new, so everything was in spec. Once I made sure everything on the bottom end of the engine was good to go, I turned the engine over, and here you can see me attaching that same dial indicator and checking the specs here for the camshaft. It looked like the camshaft had just been machined, so everything was good to go there. Then I was able to set the timing, get the timing chain installed, and really kind of get started with the disassembly of the engine. Once I got the timing chain on, I went ahead and grabbed my straight edge and started checking the deck surface as well as the cylinder heads for straightness. A straight edge is basically a perfectly straight piece of metal that's used to check to see if there's any warpage or anything like that on the deck surface or the cylinder heads. After I verified those were good to go, then it's lots and lots of cleaning, making sure all your bolt holes are cleaned out, making sure that the deck surface and the cylinder heads are free of any debris or oil residue or anything like that. The customer had supplied me with some ARP head studs here, so I went ahead and got those in and getting everything ready to put both the cylinder heads down. Anytime you are doing a reassembly on an engine like this, the fastener torque is very important. Most bolts inside of an engine have a very specific torque they should be tightened to. You can see me there referring to the service manual as I'm tightening those down, just to make sure you get the right sequence and all the right steps when tightening the cylinder head bolts. I believe these cylinder head bolts took, I think, 3 different steps of torquing. Here I'm just getting the other side. This is a V6 engine, so there's 2 cylinder heads, so getting the other side cleaned and ready to go back together and do the same thing I did on the other side. Because this engine was a little bit more rare than some of the common engines that builders put together, we did end up having a little bit of a struggle finding some parts. There really wasn't too much for wear on the rocker arms. We were able to find new lifters, that's what you see, and push rods, that's what you see there. But I was able to clean up the rocker arms, and it seemed like they were going to be okay. So it took quite a bit of cleaning to get them cleaned up to the point where I was happy with them and not putting old dirty parts in a new engine build. What I'm doing here with the red coffee can is I'm soaking the hydraulic lifters in engine oil. You want to soak them in engine oil so that you can make sure that they're lubricated inside and out when you put them back in the engine, as well as get all the air worked out of them if you're able. It just makes for, when it comes time to start the engine, it makes for a much smoother start. Once I got everything cleaned up, I got the new push rods, lifters, and rocker arms on, and got those all torqued, making sure that the engine spun over like it was supposed to. As you can see, whenever you work on an engine this deep, or really any time when you're working on an engine, a lot of time gets spent cleaning. It's really important that you get stuff cleaned before you get it assembled, not only just to prevent dirt and grime from being inside the engine, but assembling dirty components can also, mess up your assembly, whether it be torquing bolts or getting the intake or whatever to sit down properly. And that's why you see a lot of time spent using a brush or an air nozzle or something to get all that debris out of the way. What you see me doing here is cleaning the intake surfaces and getting the gaskets ready to position into place. Some of the areas there you will seal up with silicone sealer, as you see me putting on here, as well as a gasket. That just ensures that the cracks between the cylinder head and the block are sealed properly. Just like I mentioned before, there's a very specific torque sequence and pattern that you use to bolt down things like the intake. You want to make sure that you're tightening everything down at the same rate, so you don't tighten one side before you tighten the other, just to make sure it's not warped or it isn't sitting improperly. Once it came time to install the oil baffle and the oil pickup and the oil pan, we actually ran into a bit of an issue. The ARP studs that we had used for the crankshaft main caps didn't allow us a spot to bolt the oil baffle down, and actually we ended up with some clearance issues as well. So we decided to go with the factory bolts in the spots that we needed to down there. We did look at some aftermarket options as far as oil baffles go and oil pickups, but we decided that using the factory bolts just seemed to make the most sense in our case. Once we had the covers on, it was just kind of moving on to more reassembly. There was actually quite a fair amount of time spent sorting through the parts that we got with the engine. Sorting through buckets of bolts, trying to figure out what went where, whether it was a bolt or a stud, and measuring them out. And it just took a little bit of time to kind of go through some of that more tedious stuff. But once we got that nailed down, it was just moving on to the reassembly, and that was kind of the fun part. It all kind of came together once you start bolting the stuff onto the engine. What you see me bolting on here is the oil pump. It was a factory oil pump, but they had installed some fittings to have a aftermarket externally mounted oil filter. So once I was able to get that on, then just kind of moving on to the front crankshaft seal and the rear main seal, as you'll see here. Those seals can be kind of buggers to get in. They're often they fit pretty tight, and it's easy to turn them to the side and not get them in straight. So that took a little bit of time just to make sure we had sealant in the right spot and got the seal in correctly. here I am bolting on one of the brackets to the front of the engine that houses actually the majority of the idler pulleys and drive pulleys for the accessories. There's quite a few of them on this just because it is supercharged. The supercharger runs on a different belt than all the other accessories, so it's quite an assembly. One of the things we really had a lot of trouble with when we were assembling the top end here was the fuel injectors. The gentleman who was originally building this engine had upgraded the injectors. He was going to go with an LS3 injector, but they would not fit based on the way this was set up with the fuel rail, as well as the intake had been bored out to accept a larger injector. So we ended up having to source a set of oversized stock size injectors for this engine, and what we did is we had some custom sleeves machined to basically allow us to be able to fit those injectors down into the bored out intake. So that took a little bit of brain power and planning to figure out how we were going to do that. So you can see me here putting the supercharger on the top, and that was kind of, the whole project was fun, but this was really kind of a fun moment to see that all come together with the supercharger sitting on top. This is a 3.8 liter V6, not a huge engine, but you plop a big old supercharger on the top of it and it looks pretty cool. So it was really exciting to see it all come together over the course of time, and really looked really nice once we kind of had it all assembled and ready to go.